Happy Tuesday, students. I hope you're enjoying your snow day today. Stay warm and please be careful. What we're going to talk about now is we're going to continue our lesson from Monday. Let's begin first of all. Remember, you have a test on this when we return to school. Let's review this quickly. Reciprocal identities. Sine of theta equals 1 over cosecant theta. Cosecant theta equals 1 over sine theta. Cosine is 1 over secant theta. Secant is 1 over cosine theta. Tangent theta is 1 over cotangent theta. Cotangent is 1 over tangent theta. Quotient identity. Sine theta over cosine theta equals tangent of theta because tangent sine is y divided by x. Sine is your y, cosine is your x. Cosine divided by sine is cotangent of theta. Sine squared theta plus cosine squared theta equals 1. Make sure you include your thetas when you write this on your test Wednesday. Tangent squared theta plus 1 equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. And remember, you can put cotangent squared plus 1 or 1 plus cotangent squared because addition is commutative. Okay, let's start off first before I do a few more examples going over the homework. Please make sure, please have attempted the homework before you should watch a video because the more you practice, the better you get at this. Okay, so on number 1, we look at number 1. In my opinion, the left side looks more complicated than the right, so I'm going to break it down. I go through my toolkit strategies. Okay, I do not need to find a common denominator. I'm not adding, subtracting. I do not see any squares, so I'm not going to be using Pythagorean identities. There's nothing I can factor. There's no multiplication to full, so I'm just going to break this down to sine and cosine. So sine theta equals, definition of tangent, sine theta over cosine theta. Okay, I'm going to rewrite this. It's sine theta divided by sine theta over cosine theta. Now, when you're dividing fractions, leave the first one alone, change that division to multiplication, and flip it. When I do this, I can cross simplify, and I'm left with cosine theta equals cosine theta, and that's what I wanted. Okay, I'm going to do this on notebook paper because I'm not having enough room. So let me get some notebook paper. Okay, let's look at number 2. Tangent x over secant x equals sine x. Okay. I'm not adding, subtracting fractions, so I do not need to find a common denominator. I cannot use Pythagorean identities here. There's no need to factor or FOIL, so I'm just going to reduce this. I'm going to rewrite tangent as sine x over cosine x divided by, secant can be rewritten as 1 over cosine x. I'm dealing with complex fractions, so I'm going to rewrite it so I can work with it. Sine x over cosine x divided by 1 over cosine x. When I'm dividing fraction, I'm going to leave the first one alone. Change that division to multiplication and flip it. Once I do that, my cosines can cancel out. I'm left with sine x over 1, which is just sine x equals sine x. And I prove that those identities are true. That's what it means by verifying trig identities. Alright, let's look at number 3. Cosine x times secant x all over tangent x equals cotangent x. I'm not adding, subtracting fractions, so I do not need to find a common denominator. I do not have any squares in there for Pythagorean identities. Can't factor that. I can't FOIL it, so I'm going to rewrite it. So I'm going to rewrite this as cosine x times 1 over, secant can be written as 1 over cosine x, divided by tangent is sine x over cosine x. Ooh, you say that looks a lot, Mr. It does, but it's not really that bad. Because look here, what can happen to these cosines? They can cancel out. So I'm left with 1 over sine x over cosine x. Well, when you say 1 divided by this fraction, it's just going to flip the fraction to be cosine x over sine x. If you need to work that out, you can. But what's the definition of cosine over sine? That is cotangent. And that is what you were trying to prove. So I'm going to put cotangent equals cotangent. 1 divided by that flips the denominator, so now you got cosine over sine. If you need to pause at any time in the video, you may. Number 4. And then once again, this is your homework coming off page 3. You had and page 4, 1 through 12. Cosine squared theta plus tangent squared theta times cosine squared theta equals 1. I go through my toolkit strategy. I do not need to find a common denominator. Next one is use Pythagorean identity. I'm going to keep that one in the back of my mind because I'm seeing a lot of squares. Factor. That really stands out to me because you see they both have a cosine square. So that's where I'm going to start off by working. Cosine squared theta. If I take that out, that leaves a 1 there. If I take that out, it leaves plus tangent squared. And then I see up here one of my Pythagorean identities. That's going to be cosine squared theta. 1 plus tangent squared theta is equal to secant squared. That's one of your identities. I didn't have to manipulate that. Now I'm going to rewrite secant as cosine squared times 1 over cosine squared. And that works out beautifully because these cancel out. I'm left with 1 equals 1. And that is what I wanted to prove that it was equal to 1. Alright, number 5. Cotangent theta times cotangent of theta plus tangent of theta equals cosecant squared theta. Now, you could do this one of 2 ways. You could multiply the cotangent, or you could just break it down. I'm just going to do break it down, but you could do it either way. It's going to come out the same answer. Alright, so I got break cotangent down to cosine theta over sine theta, cosine theta over sine theta, plus sine theta over cosine theta. Now, if you do this way, you have to find a common denominator. Now, I'm not worried about outside quite yet. I'm just going to work inside this parentheses. My common denominator will be sine and cosine. I multiply this by cosine, I multiply the numerator, it's going to be cosine squared. Multiply this by sine, I multiply the numerator, it's going to be sine. Keep going. Cosine squared plus sine squared is a Pythagorean identity that is equal to the value of 1. There's no plus here, so I can cross simplify. Those cosines cancel out. I'm left with 1 over sine squared theta. Well, I want it to be equal to cosecant squared. Well, that is equal to cosecant, so cosecant squared theta equals cosecant squared theta. You said, Mr. Church, what did you mean by the other way? Well, if you just left it like this and multiplied, like the cotangent squared theta plus cotangent theta tangent theta, Like I said, you could have done it this way. You know cotangent and tangent are reciprocals of each other. I broke this down. These cancel out. I'm left with cotangent squared theta plus 1. That's what an identity, and that is equal to cosecant. So you could have cosecant squared theta equals cosecant squared theta. You could have done it like that. As long as you do it mathematically correct, and everything's mathematically correct, and you prove it, it's okay. But you could have done it that way. Okay? Let's look at number 6. Number 6 is 1 plus secant squared theta times sine squared theta equals secant squared theta. This looks more complicated. I'm going to rewrite this. Now, right now I don't need to find a common denominator. I can't quite use a Pythagorean identity, but I'm going to keep that in the back of my mind because there's a lot of squares. I can't factor, can't foil, so I'm going to reduce it. So 1 plus 1 over cosine squared times sine squared equals, if I multiply 1 times sine squared, it's going to be sine squared over cosine squared. Well, guys, I keep thinking about the Pythagorean identity. What is sine squared over cosine squared equal to? Hope you're thinking tangent, because isn't that identity, isn't that equal to that? Well, then I can say secant squared theta is equal to secant squared theta, because I just proved it by that line right there. Alright, number 7. I'm going to work on this side right here. I don't need to find a common denominator. I do not have any squares to look for identities. Cannot factor, cannot foil, so I'm just going to reduce everything. So it's going to be sine theta, 1 over cosine theta. Cotangent is cosine theta over sine theta. And know that this is all multiplication, so I can cross these two out. I can cross this out, and I'm left with 1. 1 does equal 1. Number 8, tangent theta equals secant theta over cosecant theta. Okay, this looks more complicated over here, so I'm going to rewrite that. I'm going to go with the right side this time. 1 over cosine theta divided by 1 over sine theta. I'm going to rewrite this so I can work with it. 1 over cosine theta divided by 1 over sine theta. And leave the first fraction alone, change it to division and multiplication, and flip. And then I'm left with sine theta over cosine theta, which is the definition of tangent. So I've solved it. I have verified that it's equal, so that is my answer. All right, number 9. I'm going to attack the right-hand side. It looks more complicated. I can't break cosine down anymore. I'm going to do sine theta. I'm going to rewrite this as cosine over sine. Where those cancel out, I'm left with cosine theta, and that's what I wanted. Okay. Number 10. Tangent squared x times cosecant squared x equals 1 plus tangent squared x. Guys, this is going to be an example where you show that both sides are equal to each other. Because watch this. I'm going to start breaking this down, this right side. Tangent squared can be rewritten as sine squared x over cosine squared x. I have to put square of both of them because that's tangent squared, times your 1 over sine squared. These two cancel out. I'm left with 1 over cosine squared x, and that is equal to secant squared x. Well, I've showed that this side is equal to secant squared. Now, let's look here. We know that that's a Pythagorean identity. 1 plus tangent squared is equal to secant squared. Well, guess what? I just showed that both sides are equal to the same value. Sometimes you have to do that. That's that other case. So now that I showed that both are equal to that, I couldn't make one become the other, but I could show that both sides are equal to the same value. Okay, number 11. I have to make a choice here, guys, on whether to start on the left or right. What is screaming to me is a Pythagorean identity. 1 minus cosine squared. So I'm going to start with the right, because I know that sine squared x plus cosine squared x equals 1. I can move this over here and I get sine squared x equals 1 minus cosine squared x. Well, I can sub that in, sine squared x over cosine squared x, where the definition of tangent is sine over cosine. So therefore, I've just proved that is true. Number 12. On number 12, I will start out, this is calling my name over here, to foil this. You've got to foil this, okay? So 1 times 1 is 1. 1 times negative sine is negative sine. Sine times positive 1 is positive sine. Sine times a negative sine is negative sine squared theta. These cancel out. I'm left with 1 minus sine squared theta. With the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. I can get it to look like this if I move sine squared over. So cosine squared theta equals 1 minus sine squared. Well, because that is equal to that, I can say that this is true. Okay, well, that's your homework, and now we're about to do a few examples. Okay, if you want to turn back to page 2 in your notebook, I'm about to go over numbers 10 and 12. We're going to omit 11, 13, 14, 15, and 16. Now, first period, I got to 10 and 12. So I didn't get to that second period, so I'm going to go over those 2, but these 4 will be new, okay? I'm going to save the rest of when we are back in class, okay? So I'm going to do this on notebook paper, but you know the problems I'm doing is page 2 in your notebook, number 10. Cosine x plus sine x tangent of x equals secant of x. I'm going to start with the left side. I'm going to rewrite this as cosine x plus sine x times sine x over cosine x. That gives me cosine x plus sine squared of x over cosine. Well, now that I have a fraction, I'm going to find a common denominator. Put this over 1. My common denominator will be cosine. If I multiply this by cosine, I got to multiply the numerator, so it's going to be cosine squared x. Well, cosine squared x plus sine squared x over cosine x. Cosine squared plus sine squared is an identity. So that's going to be 1 over cosine x. Well, I want it to be equal to secant. Well, that is secant, so I just prove secant x equals secant x. Okay, I look at number 12. I do not have a fraction to find a common. I don't need to find a common denominator. I'm going to tell you, whenever I can use a Pythagorean identity, I will use that. And see, that is sticking out to me right there. And I know that because, wait, tangent squared x plus 1 equals secant squared x. If I manipulate and move this 1 over, tangent squared x equals secant squared x minus 1. So I know that can be equal to tangent. After that, I can just break it down. And there's no plus here. We can cross simplify and everything goes away. 1 equals 1. You're supposed to do that final. I didn't mean to do equals 1 down there. Sorry. You did it at the final step. (13) Cosecant of theta times cosine of theta equals cotangent of theta. I'm going to work on the left side. Cosecant, I can break that down to 1 over sine theta times cosine theta. There's a times, that's not plus, so we do not need to find a common denominator. Cosine times 1 is cosine theta over sine theta. I got that by saying sine times 1 is sine. Well, the definition of cosine over sine is cotangent, so I just proved that identity and I'm done. All right, number 14. I do not have any fractions to find common denominator. I do not have any squares that suggest I need to look at a Pythagorean identity. I cannot factor that. Cannot foil. I'm going to try to break it down to sine and cosines. Let's just see where we go. If we run into a mistake, we start over. Tangent is sine over cosine. Cotangent is cosine over sine. Now I have fraction. I need to find the common denominator. The common denominator between cosine and sine will be cosine sine. If I multiply this by sine to get the denominator, I'll multiply the numerator. Sine times sine is sine squared. Over here, I'm missing a cosine, so I'll multiply the numerator by cosine, which is cosine squared. So I get cosine theta, sine squared theta plus cosine squared theta. There's an identity. Sine squared plus cosine squared is 1 over cosine theta sine theta. There's no plus here. It's multiplication. I can cancel those out. And I get 1 over sine theta. Well, I'm trying to prove it equal cosecant. That's the definition, so cosecant theta does equal cosecant theta. You can pause the video at any time if you need to review a example. Number 15, I do not have fractions. I do not need to find a common denominator. There's not a situation that calls for Pythagorean identity. I can't factor. I'm going to foil that. Secant times secant is secant squared theta. Secant times 1 is positive secant theta. Negative 1 times that is negative secant theta. Negative 1 times 1 is negative 1. These cancel out. I'm left with secant squared theta minus 1. And that looks like a Pythagorean identity. I'm going to come over and see if I can manipulate it. If I move this 1 over, I get exactly what it's up here. So I wanted to prove that's equal to tangent. This is equal to tangent. So that's my answer. Oop. Let me just rewrite that. 16. Sine theta plus cosine theta squared plus sine theta minus cosine theta squared equals 2. I do not have any fractions. Find a common denominator. I don't have anything shouting Pythagorean identity. Factor, I can't do that. I'm going to try to foil because these are squares. So I'm going to come over here to the side. Or I'm going to come right above this. If I said sine theta plus cosine theta times sine theta plus cosine theta, let's see what happens. Sine times sine is sine squared. Sine times cosine is positive sine theta, cosine theta. Cosine times sine is another positive sine theta, cosine theta. Cosine times cosine is a positive cosine squared theta. Okay? Now, I'm going to FOIL this. Sine theta minus cosine theta times sine theta minus cosine theta. Sine times sine is sine squared. Sine times negative cosine is negative sine theta, cosine theta. Negative cosine times sine is negative sine theta, cosine theta. And then a negative cosine times a negative cosine is a positive cosine squared theta. Ooh, we got a lot going on here. Okay, let's combine like terms. A sine squared and a sine squared, that's 2 sine squared theta. Now look here. This is sine theta, cosine theta, sine theta, cosine theta. Then I have a negative sine. I can cancel one of these out with this. Cancel the other one out with the other. Now I got cosine squared and cosine. That's plus 2 cosine squared theta. Now, inside of that, right here, I see a Pythagorean identity. I see sine squared plus cosine squared. But I see a 2. That's keeping me from doing that. Well, I can factor out of 2, because they both have a 2 in common. And now I know that identity is equal to 1. So 2 does equal 2, like I wanted at the beginning. Okay. We're going to stop right there for examples. But these are some problems I want you to work on for when we do come back to class. On page 4, I want you to circle number 13, 14. You did 1 through 12 already. Do 13 and 14. Hold off on 15. We're going to do that in class. Do 16. $18. I want you to try 15. Now don't get stressed, because I will help you with it, but it's finding the common denominator. Common denominator between 1 minus cosine and 1 plus cosine would be both of them. So just try that. Let's see. I want to see. I challenge you on that one. But the other one should be fine. So 13, 14, 15, 16, and 18. And we're going to discuss those in class when we return. Okay. Thank you. Have fun and be safe. I really appreciate you watching this video, so I'll see y'all when we get back.